NASA released data that could completely change our understanding of space. Signs of life were discovered on a distant planet with a probability of 99.7%. This planet is K2-18b, located 124 light-years away from us. In its atmosphere, chemical compounds were detected that on Earth are almost always associated with living organisms. Moreover, their concentration is 1,000 times higher than on our planet. If these substances are truly the result of biological activity, as they are here on Earth, then right now there may not just be life out there, but a thriving ocean of biological diversity. Amazingly, everything points to K2-18b being a water world, a planet covered with deep oceans hiding active life. Life that might be completely unlike anything on Earth. (2015). The Kepler Space Telescope, having begun its K2 second light mission, scans the depths of space. Over the course of this mission, it discovers more than 1,200 distant planets. Among them, one especially captures scientists' attention. A planet with mysterious signs of potential habitability. It's almost 2.5 times larger and nearly 9 times heavier than our home planet. Scientists name it K2-18b. 2017. The Spitzer telescope joins the research. It confirms that K2-18b is located within the habitable zone of its star, precisely where liquid water could exist on the planet's surface. Almost at the same time, a scientific observatory in Chile, using the precise HARPS spectrograph, determines the planet's density, suggesting the presence of an ocean. The stakes rise. More and more signs suggest that life might exist on this planet. 2019. The Hubble Space Telescope makes a new discovery. Water vapor is detected in K2-18b's atmosphere. The possibility of a deep, life-supporting ocean no longer seems like science fiction. Hope becomes tangible. 2023. The most powerful modern telescope, the James Webb Space Telescope, comes into play. Its sensors detect something that instantly shocks scientists. Traces of a chemical compound known as dimethyl sulfide, DMS, a substance that, with rare exceptions, is almost always produced by living organisms on Earth, such as phytoplankton and other marine microbes. If this isn't an error, scientists may have found signs of life beyond Earth for the first time. Still, there wasn't complete certainty. There's always a chance it could simply be a mistake. The data might have been distorted, especially since the initial measurement was taken by a single instrument, the James Webb Space Telescope's near-infrared camera, and distinguishing dimethyl sulfide from, say, methane in that range is very difficult. Scientists were faced with a reasonable question. What if it was a glitch, or a peculiar way the instrument operated? To check, NASA decides to conduct repeated observations using a different instrument and a different method. If both independent devices showed the same result, it would be possible to declare a real discovery. April 17, 2025. The James Webb Telescope uses a new instrument to perform a repeated detailed scan of K2-18b. This time, it's a camera operating in the mid-infrared range. The results are staggering. Signs of dimethyl sulfide are detected once again, and its concentration may be colossal, 1,000 times higher than on Earth. This isn't just any rare gas. Dimethyl sulfide is quite unusual. On Earth, it appears when microscopic algae like phytoplankton begin to decompose in the ocean. In the process of their decay, this gas is released, easily evaporating and rising into the atmosphere. And if you've ever walked along a seaside during windy weather, you've definitely smelled it. Dimethyl sulfide is what creates that characteristic ocean smell, impossible to confuse with anything else. But it's not just about the smell. This gas has an important property. It's very unstable. In the atmosphere, it survives only for a few days, quickly destroyed by sunlight and oxygen. This means it can't just hang around. It has to be constantly replenished. And on Earth, this replenishment is almost always linked to life. That's why the discovery brought so much awe to the scientific community. The concentration of dimethyl sulfide in K2-18b's atmosphere turned out to be 1,000 times higher than